Let us start this lecture with a nice picture. What you can see on the screen is a nice spiral which is expanding outwards from the center, going round and round like this. What is special about this spiral is that it's actually made out of circular arcs. Actually, this is one quarter circle here, a small quarter circle, another small quarter circle. Now you have a slightly larger quarter circle, then an even larger quarter circle, even larger one, even larger one. So notice that these squares that have been drawn here are actually showing you that basically the overall spiral that we see is made out of bigger and bigger quarter circles. And there's something special about the radii of the quarter circles. Notice that these two have the same radii, let's say 1 and 1 each. After that, this quarter circle is just big enough so that it covers the diameter of these two, which means it has a radius of 2. Now this one actually manages to cover this side which has side 2 as well, and a side 1. So this is radius 3. Now we have a radius 3 circle, and these two together made up radius 2. This one is radius 5. Now this one is radius 8. So if you think about it a bit, how are these radii changing? You started with 1 and 1. The next one was 1 plus 1, 2. The next one, 3, was actually 2 plus 1. That is, you added the radius of the last quarter circle to the one before that. Then this one, 5, was actually the radius of this circle 3 and plus the radius of this circle of radius 2. So 3 plus 2 gave you 5, 3 plus 5 gave you 8, 5 plus 8 gave you the 13, 13 plus 8 gave you this 21. Of course, if we continued further, you would have radii of 34, that's 21 plus 13, and so on. Now, many of you may already be familiar with a sequence of numbers which goes like this: 1, 1, 2, 3, 5, 8, 13, 21, and so on. This sequence is what is called the Fibonacci sequence. It was named after an Italian scientist from the medieval times. And what we are going to do today is we are going to play with this particular spiral, which is called the Fibonacci spiral in his honor, as well as the Fibonacci sequence, and try to see how various Python constructs can be used. Some of them we are going to learn in this lecture as well, and we are going to see how these constructs are going to be used to investigate the sequence a bit more. But first, let's try drawing the spiral, and for that, let's go back to our Python interpreter. What we have done, of course, is that we have started the Python interpreter. Okay, maybe since I've been using Python 3 for the past few lectures, I will switch to Python 3. So I will get out of the Python interpreter, which is Python 2 by default in my system. Clear the screen. This has nothing to do with Python. It's really a Linux command which clears out the terminal. And then I will invoke the Python 3.7. That's the version I have on my machine of Python 3 by using the command Python 3. So now I've started the Python 3 interpreter. As I said in the very first lecture, the differences between this one and Python 2, if you are using that, are rather slight. So most of what I'm going to do here will go through perfectly without any changes. Of course, I need to import, or rather use this mantra that we have talked about several times now, from turtle import star, and now we're ready. Let's use our familiar reset command to get the canvas in place so that I can move it to where I can see it properly without my terminal blocking the view. So I'll reduce the size of the terminal a bit, and then, as always, set the width to 3. And now what I will do is start drawing this spiral. Now, notice that I already know how to draw quarter of a circle, right? What we can do is we just say circle. Let me just remind you of that. This is a turtle command, circle. Follow it up with the radius 100 and then 90. Why 90? Because I want to draw a quarter circle. So 1/4 of a circle is drawn. The only problem with this one is that if I start this way, I can actually get the Fibonacci spiral, but this version will be rotated a bit, rotated through 90 degrees, compared to the one we wanted. That's because our spiral, the one in the picture, started out downwards like this, went counterclockwise, the circle went counterclockwise, but started moving down, and then went on. This one started horizontally, so it's going up like this. So in order to get a circle like that, what we need to do is start all over again, resetting, setting the width, and then what I will do is I will first turn the turtle so that the turtle now faces downwards to begin with. That means I have to turn it to the right through 90 degrees. So now the turtle is facing downwards, and now if I say circle 190, I'm going to get a quarter circle moving in the initial direction that my picture really was doing. So what do I do now? I really need to draw circles with radii going along according to the Fibonacci numbers 1, 1, 2, 3, 5, 8, 13 and so on. Of course I can do that by hand by giving these commands one after the other. The only problem with that is if I draw a circle of radius 1, that's way too small to be seen. If on the other hand I use, instead of 1, 1, 2, 3, I use 100, 100, 200, 300, 500 and so on, the circles will very soon become so big that they will just go out of the screen. So let's say instead of doing either, let's use 10, 10, 20, 30, 50, 80 and so on. In this case also, we have Fibonacci numbers. We have started with 10 and 10. Every subsequent number is found by adding the last two. So let's just do that by hand first. Let's first turn right through 90. Okay, before I forget, let's change the width back to 3. And then what I will do is I will draw a circle now, but with radius 10. So I've got a small segment of my spiral. Then starting from this very same point, I will draw the next circle, which is again not a circle, a quarter circle. That's what the 90 argument, the second argument of circle is doing, is telling the turtle not to go through with the whole circle, but only go through 90 degrees. So again, a circle of radius 10, but only 1/4 of it. Fine. Then I will draw a circle with the next Fibonacci number as radius, that's 20. Of course, the Fibonacci number is 2. I'm just using 10 times that. And then I will draw a circle with the next one, which is 30, which is 10 plus 20, of course. Notice that the spiral is already taking shape. I could do 50, which is 20 plus 30. The next one will be, of course, radius 80. The next one, 80 plus 50, right? 130. And then 210 and so on. I can keep on going. I can keep on going further and further down the line with this. Now, this is fine, but one thing we have learned in computers is that if we do same or similar things over and over again, it is not a great idea to just keep on typing the same code with small changes over and over again. It's best to try to put the whole thing in a loop. So what kind of loop will I use here? So let's first start by assuming that somehow I have created a list of the first few Fibonacci numbers. Now that's pretty easy actually. Let's call this the Fib L Fibonacci list. And the numbers, I can just create them by hand. I can put in 1, 1. The next number is the sum of the 2, then 3, then 5, then 8, then 13, then 21, then 34, and so on. Let's stop here. So now that I have a list of the Fibonacci numbers, I can use this list to create my Fibonacci spiral. So how do I do that? Well, I just run a loop. But before that, let's wipe our slate clean. And let's put the width back to 3 and turn right through 90 degrees just because I want the spiral to have the same orientation as in the picture that I had drawn. Otherwise, I would still get a Fibonacci spiral. It will just be turned counterclockwise through 90 degrees compared to the picture that we had. Okay, now I'm pointing nice and down, and then I will use a loop. Just to remind you, the loop that we're going to use here is the for loop, and the basic hidden line of the for loop is for followed by variable name, in, and iterable. Here the iterable is the list fib underscore L that I have produced, and all I will do is for L in fib L, which means L will take values successively of 1, 1, 2, 3, 5, 8 every time the loop runs. Let me remind you once again that the header line has to end with a colon. And now for L in fib underscore L, I will draw a circle. Now I will draw a circle not with the radius L because that will be too small. Let's draw a circle with radius L times 10. And remember to draw a circle only up to 1/4 of its extent, that is only up to 90 degrees. That's the second argument. And I'm done. This will work fine. Let's see. This loop will give you the answer. Yep. Of course, this time the Fibonacci spiral went a bit further simply because I have one more term here. I've added 34 to the list. Of course, I could have added the next one and I would have got an even bigger spiral and so on. So now that we have drawn a rather interesting looking curve on the screen, just by using the Fibonacci numbers, let me now ask, can we think of a way to create the Fibonacci numbers? Well, one of the ways is simply by using the packing unpacking idea that we had used before. What we do is something like this. We first define two variables, A and B, and assign them values of 1 each. So A is 1, B is 1. These are the two starting points of my Fibonacci sequence. So I'm now trying to create the sequence 1, 1, 2, 3, 5, 8, or at least I'm trying to get the computer to create it for me. So what I will do next is something like this. If I did B comma A plus B, what would happen is the first element would take the value of B and the second element would take the value of A plus B. And of course, what I'm getting here are two numbers separated by a comma. And remember, the standard convention in Python is whenever you separate two objects with a comma, the thing that is returned is a tuple, not a list, not anything else. It's just a simple tuple. Here, of course, they have 1 and 2. Now, what I want to do next is something like this. Remember, A was my first number, B was the second one. These are the two numbers which I should have added to get C, the next one. But if I keep on using new variable names, A, B, C, D, E, F is going to be very difficult to keep on continuing, especially because we are going to run out of the alphabet soon. And then what do we use? Double alphabets, double letters, triple letters. Of course, we could do that, but then I would have to keep on writing the code over and over again, changing the name of the variable every time. A much better idea would be to keep on calling the last two numbers in your sequence A and B respectively. What that means is, first time A and B are 1 and 1, but now that I've added them and got a 2, next time A and B have to be 1 and 2. This one is the second of the two ones. The next time, when I add these two to get a 3, the next time A and B should be 2 and 3, and so on. So how do you achieve that? That is where packing and unpacking comes in. If you use this simple expression, what you get is, first B and A plus B are packed into a tuple. So the tuple is 1, 2 in this case. And then they're unpacked. So the value of B goes into A, and B itself changes to A plus B. The next time around, if I repeat this, again the last two, these two numbers A and B, well, B will go into A, and the new number will come out, which is sum of these two, and that will go into B. So let's see how this works out. If I do this, A is now 1, of course, B is 2. So I've got the next entry in the Fibonacci sequence this way. So let's try doing this, and let's go back and reset the values of A and B to 1 and 1. Of course, I could say A equal to 1, B equal to 1, but packing and unpacking works here as well. We have created a tuple 1, 1 on the right hand side. That's now unpacked into the variables A and B. So now A and B are 1 and 1. Let's say I want to create quite a few numbers. So let's say just 10 times. I want to run a loop 10 times. And what does this loop do? It just carries out this packing unpacking thing that we talked about. Sorry, B. So A, at the end, A will change to the current value of B, and B will change to the sum of the current values of A and B. And the new number that I'm getting is of course now in B, so I will just print B for you. And this is where Python 3 is important. The distinction between Python 3 and 2 is important. In Python 2 I would have just said print blank B. In Python 3 I have to say print. Now it's like a function, so I have to call it with an argument. What I want to print. So let's see. I had 1, 1 already. Then the new Fibonacci numbers 2, 3, 5, 8, 13, 21, 34, 55, 89, 144 are being created. Great. But how do we do this and store these numbers in a list? Of course, if I wanted to draw a Fibonacci spiral, I had to create a list at the beginning. The list of lengths or radii of these circles. So how do I create a list like this? Well, I can always make a start by doing this. Let's create this fib underscore L list. Of course, we already have one. But let's create it with just the two starting numbers, 1 and 1. Okay? And what we do is we unpack the fib underscore L into A and B, two variables. Notice unpacking works as long as you have an iterable on the right hand side and the number of variables on the left hand side is equal to the number of elements in the iterable. Doesn't have to be a tuple, could be a list as well. So A comma B is fib underscore L. Fine. And then what we will do is we will create a list, let's say even a bigger list this time, let's say 20 element list, 20 more elements rather. That means we already have 2, so in the end my Fibonacci numbers, there will be 22 Fibonacci numbers. And what I will do is something like this. I will calculate the new Fibonacci numbers using this packing and unpacking trick that I talked about. Fine. However, now that I have found the new Fibonacci number which is in B, it will be in B every time the loop runs, the next Fibonacci number, I mean. How would I store this number in the list? Now you might say, simple, just use fib underscore L has indices 0 and 1 and just say fib underscore L 2 is the next number, 3 is the next number, and so on. But that will not work, simply because at its current stage fib underscore L has only 2 elements. It's a length 2 list, and because it is a length 2 list, the only indices it has are 0 and 1. If you try to assign some value to fib underscore L square bracket 2, Python is going to raise an error. It's going to simply tell you that there is no index 2, it's a list index out of bounds error. So the question is, how do I make the list bigger? That is, I want to add more elements to the list. It so happens that there is a pretty easy thing to do. But for this, we have to learn a new command or new method. So this is a method which is tied to the list. It's every time a list is born with certain methods which can be used on it. Right now, fib underscore L is our list, and like all lists, it has several methods, and this particular one is called append. Notice how we call it. We call it in this particular format. We name the list first, fib underscore L, and then put a dot after that, and you say append. That means what we are saying is this object here, fib underscore L, has an append method, use that one. And what do I append? I just append the number b to it. So what does append do? It just increases the length of your list by putting in whatever argument you're giving it as the next element. So the list which had 2 elements now becomes a 3-element list. Then next time around it will become a 4-element list, and so on. So append is a way in which you can make a list grow. Let's see. Right, we have got a perfectly large list now. In fact, if you look at the length of this list, which we can do by using the len function, it is 22. We started with 2 elements, and we now have 20 more elements because a loop ran 20 times every time a new element was appended. And as you can see, the numbers are actually increasing pretty fast. Okay. So now, how do we use this to draw a spiral? Now that we have the list, the thing is straightforward. We go back, set the width back to 3, and let's turn right 90. But this time, because the final length is already very huge, what I will do is, instead of saying for L in, okay, that's taking too long to get back by using the arrow key, so let's just type it out. Well, fib underscore L has 22 elements. If we use all of them, the last one will have radius of 17711. That's a bit too big. So for the time being, what I will do is something like this. I will just say circle, and instead of multiplying L by 10, let's multiply by only 5 this time. 90, and because I don't want to draw too big a circle, what I will do is something like this. I will use an if statement. If L exceeds say 300, then we will stop this loop. So there is a command in Python which allows you to stop a loop. That's called break. If you use the break command, the loop will stop and command will come out of the loop. That is, then the interpreter will be ready for your next command. Whatever was going on in the loop, that stops. Of course, you don't want to really put a break just like that in the middle of a loop, because then the loop will only run until the break command is met and then stop. It will not be a loop at all. But you can, of course, often put break command inside a condition within the loop. So here, for example, at the beginning L is 1, 1, 2, 3, 5, 8 and so on, and these things are going to work out. These circles are going to be drawn. Only when L exceeds 300, the break will be encountered, and once it breaks, it goes out of the loop, which means the next elements will not be even read. Let's see what happens if I do this. The spiral is being created. Now, of course, even at 300, this is actually way too big. It's going out and drawing bigger and bigger circles outside our field of view. But now, let's stop. However, okay, this is not the only way in which you can just draw this using a part of the loop. What you could do is something like this. Just to remind you once again, when I want to talk a specific element of a list, we can use something like this. This will return to me the 3th element, which is of course 4th element in common English. Counting, remember, starts from 0. 0, 1, 2, 3. So this will give me the 3th element of the list fib underscore L, which in this case, as you can easily check, this is the 0th element, 1 is the 1th, this is the 2th, this 3 is the 3th, so this should give me 3. Okay, and say 10th element will give you 89. That's the 11th element in standard language. Now, if I want to actually get a part of the list, can I do that? Not just one element, but some consecutive elements. The answer is I can. And doing that is called taking a slice out of the list. How does this work? Well, to see what this is going to do, let me just flash fib underscore L, the whole list on the screen once again. And now that you have the whole list, you can see what this is. 1, 1, 2, 3, 5, 8, 13 and so on. Let's say if I do something like this. I'm using the square brackets once more, but instead of giving one index, I'm giving 2 separated by a colon. This actually will give me all elements from fib underscore L from the 3th and onwards. Well, it might seem until the 10th, but not 10th. It will be only up to the 9th. This is, of course, the same convention as is used in the range function. You have a start, you have a stop, but you don't really go all the way up to the stop. You stop one shot, or you just don't touch the stop. If you do that, let's see what happens. I'm getting the 3th element, which is 3, the 4th element, 5th, 6th, 7th, 8th, and 9th. The next element would have been the 10th, and because my number here is 10, that will not be touched. So this is called taking a slice out of a list. So what has happened is I've sliced out a piece of the list for me. The piece which starts at element number 3 and goes on until just before element number 10. Well, you can actually do more. You can do something like this. And you should be able to guess what this is, especially, or what this will do, especially after what you have learned about the range function. What this will do is give you the 3th element, 5th, 7th, 9th. So, from 3 in steps of 2. So this is of the 3 parts of the slice. This is the start, this is the stop, and this is the increment. Of course, you realize that earlier we did not give the increment, which gave the increment its default value, which is 1. Well, I don't even have to give the starting value. We just said up to 10. What does it mean? I have not told Python where to start the slice, So by default, it starts at the beginning. So I'll get a longer list this time. The initial 1 and 1 and 2 are also in 1, 1, 2, 3, 5, 8, right up to 55. That is the 9th element. 0th to 9th. All 10 elements. Similarly, if we had done something like this will be 10th. And this time 10th of course is in till the very end. Okay, so if you just use a colon with a blank, the blank takes its default value. If the blank is before the colon, the default value is 0. The blank is after the colon, the default value is the is the length of the list. And if I just do this, it will actually give to me a copy of every element of the list. This may seem to be a useless thing because I already have fib_l, but as you will see later, this actually has a great deal of utility. But in general, this is how slices work. Take a piece out of a list. In fact, does it work only for lists? No, it works for all iterables, lists, strings, tuples, you name it. So, if I started with and then took a slice. So how do you take a slice? Is how you get a single element, that's the 3th element. Suppose I said 1 colon 4, that would mean start at element number 1, which remember is P, then go on to element number 2, then element number 3 and stop there. So PPL. So you can take slices out of strings as well. Also out of tuples, exactly the same way as you can change things out of lists. Okay, so how do we use slicing to help? Well, in creating the Fibonacci sequence. Before we go there, let me just try to show you another way of creating the Fibonacci sequence by using whatever we have learned, but without using these extra variables A, B and so on, unpacking and so on. So this is actually pretty straightforward. We start with the fib_l list once again, the beginning list, which is just 2 elements, 1 and 1. Of course, since every element is formed by adding the last 2, for this thing to start, you will have to start with 2 elements. And then what I will do is something like this. Again, run a loop, let's say 20 times as before. So the header line is complete. Then what I will do is something like this. I will, instead of using the a comma b equal to b comma a plus b trick to create the new value of b, I will just use this. What I want to do is add to this, append to this fib_l list a new element. What is this new element? The new element is just the sum of the last 2 elements. So how do you refer to the last 2 elements? Well, the last element is -1, index -1. And that's it. So you don't need any other variables or anything. All you're saying is the list has a number of elements. What I will do is just take the last 2 elements of the list at this stage and then add them together and just append that result to my list. So next time the loop comes around, the last 2 elements of course will be what used to be the last element beforehand, last time around, and the new element you have just calculated. And then you keep on doing this. And of course, if I do this and check what fib_l has, I'll have exactly the same list as before. The only thing is I did not have to bring in this additional variables a and b to do this. And finally, can I use a slice? Let me just show you that this thing. Suppose I did. So what will this say? We'll start with element number -2, which is last but 1 element of the list, and go on till the end. right? So this slice gives me the last two elements. And if I just use the sum function, which is rather obvious, what does sum do? It just adds up whatever elements you have in the list. This sum function will work only if you have given to it as an argument a list or a tuple made of objects which can be added together. And it just nicely adds these things. So I can actually simplify the code I wrote a while ago. Let's start with fib_l again at the same value. And then what I will do is, for I in range 20, I will append to fib_l to make it grow the sum of the last two elements of fib_l. So whatever fib_l is currently, you will take the last two elements of that by taking this slice, sum it up by using the sum function, and then, and there is something critical which I missed. What I need to do is not what I wrote a while ago. That would have given me an error because I could not use round brackets with fib_l. Fib_l is a list. Round brackets are for function arguments. But what I use here is fib_l dot append, the append method or append function is tied to the list fib_l. Every list has the append function. And what does it do? Whatever argument you give it, it pushes it to the end of the list. And once again, let me just check whether it has done my work properly. And it has. It has given you back the same bunch of numbers. So in this lecture, what we learned is ways of manipulating a list. That was really our major concern here. A list can be brought to life with a certain number of elements, but you can always use append to add more and more elements to it. Before we end this, let me just introduce one more function which a list has. And for that, let me just start with a simple small list 1, 2, 4. And let's say I have another list P, which is 5, 6. And what I want to do is put the elements 5 and 6 after 1, 2, 4. Now one way of doing that is something which may look a bit strange. If you just use a plus sign between A and B, it will add the list. Now what does adding lists mean? What it means is, it will just take the elements of the list A and the elements of the list B and concatenate them together. That is, just put them together in a single list. 1, 2, 4, 5, 6. That's exactly perhaps what you wanted. The only problem is, A is still 1 to 4, B is still 5, 6. What this has done, what A plus B has done, is given me a new list, returned to me a list with elements 1, 2, 4 and 5 and 6. Of course, if I wanted to change A to this new value, I could have written something like A equal to A plus B. Then the list, origin list A is not changing. All you're doing is you're calculating A plus B by joining them together. That's what plus means for list. Returning a new list, and this new list is now pushed into the variable called A. That can be done. But can't we just use the append method here? Why can't we say something like this? The list A, if I wanted to change the list A, the list A has 1 to 4. If I just say append B, will that work? Well, actually it will and will not. Most likely this is not what you wanted. Notice that what append does is takes whatever you have given as an argument, takes it as one piece and makes it the last element of the list. So A was 1 to 4 originally. Now its last element has become the list 5, 6. I guess you did not really want this. I guess you wanted a list with elements 1, 2, 4, 5 and 6. Not a list with elements 1, 2, 4 and the list 5, 6. So if you wanted that, okay, now of course you have to undo this thing that you have already changed A. So let's go back to A is this. And rather than use append, what you would like to use is something called extend. So what you are doing is you are telling Python, extend the list A by using the iterable B. So now this is what we wanted. If 1, 2, 4 and the elements of B have been unpacked and put next to each other in the new list. By the way, can you guess what will happen if I did this? If we had used a.append apple, quote apple, that is a string, then the string apple would have been the last element, would have become the last element of A. Here on the other hand, the string apple is broken up into its constituents and each constituent is put in as a subsequent element of the list. Notice now what has happened to A. You already had 1, 2, 4, 5, 6. Now the elements A, P, P, L, E, which are individual elements making up the string apple, they have been made distinct elements of the list A. We will discuss a lot more about lists and strings and their methods in the next lecture. Bye for now.